Hello and welcome to this webinar on AI utilisation in broadcast and film applications. Thank you for joining us on this Leap Day today. So first of all, I'm just going to introduce myself and the Media Technical Network, and then we will begin our webinar. So my name is, oh, it's not changing. My name is Polly Hickling, and I'm a Learning and Development Lead for Media at Everton, and also a member of the IET Media Technical Network. We've been putting together a series of what we've called the Field Studies lectures. We've already had a real face-to-face lecture last month, and we've now got a few online webinars that you can join us for, all under the kind of theme and banner of AI. So there's a recording of our previous one if you want to catch up on that, and I'll tell you how to do that in a second. And our next one, if you want to join us for that after today, is on driving metadata with AI, a responsive narrative factory. And that will be at 1 p.m. on the 4th of April. And I think if you follow that QR code there, you can log on for that one. You can also follow us on our no longer called Twitter, but I'm going to call it Twitter anyway, at IET_media. We've also got our LinkedIn, which we're fairly active on, IET Media Technical Network, and our YouTube channel, IET Media Network, where you can see years of previous recordings that we've done, and also some of our latest content as well. So enough about that. We've got a lot to cram in to this hour's webinar. So I will introduce Richard Welsh, who is Senior Vice President at Deluxe. I'm just going to awkwardly stop sharing that now and hoping that Rich will just pop up. If I just escape that view. There we go. In my speaker view. Yeah. So Rich, I've known Rich for a long time, since his days working at Dolby, and after Dolby, Rich had his own company called Sundog Media Toolkit, which was then bought by Deluxe, and he's pretty much always been working at the cutting edge of technology, which is really what he's here to talk about today. He also taught for a little bit at Solent University, teaching media technology students, and he is also the Executive Vice President of SIMPTY, which is another media-related network that you can join should you be interested in the content that we've covered today. So Rich is going to be talking today about AI, and we joked when we kind of started talking about this presentation that the content that you were going to be delivering would be out of date by the time we got to today, and this has actually happened, isn't it? So I'm really excited to hear what you've got to talk about, as it is literally the most up-to-date version of this. So I will let you kind of open up your slides, and we've also got some polls and some questions to ask you as we go along. And then there'll be a chance for you to ask questions at the end as well.
Cool. Well, thank you for inviting me to talk, and I really appreciate it. I'm 8 hours away from you guys in LA right now, and working on some AI applications that we're hoping to roll out within our business. I've actually I've been looking at this for quite a while, before it really was AI was the sort of umbrella term. I used to find that one a bit of a troublesome term, because artificial intelligence, maybe deep learning networks, I think, and neural nets are probably more appropriate description of what we do today, and also now transformer networks, which have been made popular by ChatGPT. So with that in mind, if possible, I'd like to run a quick poll just to see who in the audience has tried ChatGPT for themselves. So yeah, if we could run that poll, that would be great. So it's super easy. And I've got a sneaky suspicion that I know the answer already, because I've been in a few presentations recently where we've asked the audience this, and some people have been surprised at the answer, but I have started to get used to it. But let's see what this audience says. How long do we keep the poll open, Polly, before we see what the results are?
I think we could go. Yeah, I mean, I think
reckon
we're kind of getting the answer that you were expecting here, I think. So I'll give it another second, and you can talk about the results, and then I'll end it.
Okay. So yeah, I'm fully expecting that nearly everyone, if not in fact everyone, has already tried ChatGPT. And this is kind of going to be, I guess, the overarching sort of theme today is, 37% no. Well, that is interesting. That is actually, that's a higher number of people who haven't tried it than I was expecting, actually. So that's good to know. There will be some links to various tools at the end of the talk, but honestly, that one's the easiest one to find, because you just Google ChatGPT and you can find it and try it. I would suggest going and having a play with it just to see what it does. It's quite impressive response tool. I think that's the best way to describe it. You can ask it something or give it some information, and it will respond in the way that it believes is the correct sort of natural language response to whatever you've asked it. A lot of the stuff that I'm going to show you today is built on top of that as a foundational technology. And some of the other stuff I'll show you actually uses it to refine other types of AI network. And I'll dive in a little bit more into sort of general deep learning and machine learning networks and attention networks, which is what ChatGPT is based on, a bit later. Let's start by having a look at, what areas do we use AI in media? What areas are sort of emerging as well? Honestly, it's sort of being used everywhere. I mean, it's in our everyday lives. It's embedded in mobile phones. It runs behind lots of different tools that we use every day, like search and so on. And it's making its way into software as a component, just an everyday component, in fact, of things like Photoshop and so on. With that in mind, I started to make a list of areas that I have been looking at, and I realized it was just silly, because this list could easily be doubled. So there are loads of places in which you can use AI in media, and it is being used now. And it's actually, some of the applications are really genuinely transformative. They are changing what we can do when we're creating content. Some of them are more around efficiency and automation, but we're seeing a whole new generation and style of filmmaking emerge from these technologies. I'm going to, as Polly mentioned, there was a release of, an early look yesterday of some software which will be released in the next month, I think. I don't have a slide on it, but I will talk about it later. It's going to completely change that part of my talk, which was going to be around generative video. But I will also show you some examples, and we'll walk through things. The other thing to say here is that almost all the images that you will see here today are from AI. In fact, I think all of them are somehow generated by AI. Even the graphs are just showing you results of AI algorithms at work. So with that in mind, anything you see here today was generated. And we'll talk about who owns those images a bit later, because it turns out it's not me, even though I asked for them. So I'm going to start by talking about a project we did back at Sundog probably 7 or 8 years ago now, which was around color. And this is something now that, again, there's lots of tools on open tools on the internet that do what's called style transfer. So you can take the color and look from one image and apply it to a different image. So your source color and appearance can then be applied to a different image. Now, what we were trying to do back in, I guess it was 2017, with this color AI was to basically take the grading decisions of a colorist. So in film and TV, we take what comes out of the camera and we put it through a process called color grading, where we balance the colors and generate the look that we want for an image. So for different types of genre and different types of scene, where you're trying to use the color to convey emotion, you play around with the balance of the color in the image. And we wanted to be to see if we could learn that style and then apply it to more content. So this was based on deep learning networks. And the reason I've started with this is it's not probably the simplest concept of the things I'll talk about today, but it was using what is now considered to be somewhat passé in the AI world, which is a deep learning network. Now, the advantage of a deep learning network is that although it takes a lot of data to train one, once you've got the trained network, it's very lightweight when you're using it, and I'll talk a bit more about that in a few more slides. So the principle was we created a base model, and then we would train the base model using a subset of a feature film. So it would be some example frames from a feature film or from a TV show, and then we'd use that to apply that color to the rest of the show. So it's what we would describe now as a small data AI. There are different methodologies for applying a small amount of data to effectively move an AI in a certain direction and make it sort of task specific. And I'll talk a bit more about that. And there's a very popular one now used for generative AI known as LoRA, which is low rank adaptation. But that wasn't what we were doing here. We were literally taking a big subset of frames, taking the base trained network and then retraining it with the new frames to kind of move it in the right direction of the effective look of that particular piece of content. So it was a deep learning network, as I mentioned, which was trained on a very large data set of a lot of different types of movie. And that was then, as I said, created the base model, which we fine-tuned. Now, what was very interesting about this was that when you looked at the input-output correlation, which I'll now show you, you could see actually between genres, it was surprising how similar they actually appeared. They were somewhat different. So what you're seeing here is the red, green, and blue channel input-output correlation from the AI. So it's literally was working on the pixel level, so it was changing every pixel. And actually, what was very interesting about this particular AI was it did not look at all the pixels together. It literally looked at individual pixels, and to our surprise, without having any understanding of the relationship between one pixel and the next, it was actually able to regenerate the color that we were expecting. And what you can see here are a few examples of real movies. So I think the top row, the period dramas, I think on the left is The Prestige and on the right is Pirates of the Caribbean. So there's some differences you can see in the green, blue, the blue in particular. There's a bit of a difference there in those input-output relationships. But if you look at the family animation, you can see that, for instance, the red and green channels are have a much wider spread between the input and output. And if you use for instance, the Prestige to color grade, the Prestige trained AI to color grade pirates, you'd get a result that was not far off what you wanted. If you use the Pirates trained AI to color grade pirates, it was much closer. As you can imagine, it was in fact what you were trying to go for. So we did find that although you could train for a genre, and that produced pretty good results, actually what worked best was to train on a specific title. But what we were surprised about was that we could use a very small number of frames and get to a very close approximation of the desired color, even as low as a handful, maybe eight or 10 frames of the movie was enough to train the AI. And that is now one of the core kind of techniques used with generative AI, is to take a very small number of pictures, for instance, and use those to guide the AI in terms of the style that you want to apply to your generated image. And we'll come back to that a little bit more later. So just because I don't normally get to see these things, this is this little animation. It's a bit of a loop, but it's basically the AI learning through training epochs. So each time you train the network and test it and see how good it is, that's known as an epoch. And you keep doing that. This was around 10,000 training epochs compressed into a few seconds of video. And what you'll see at the start, in fact, because it's because of the frame rate here, you won't exactly see it, but at the very start, the frame's actually black. There's no image whatsoever. And then it starts to learn the luminance component, so the brightness in the image. And that's why you see a black and white image to start with. And then it starts to learn the tone of the image, which is when it starts to look sort of sepia, like an old-fashioned photograph, which is complete coincidence. It's nothing to do with photographic technology. It's just how the network was learning. And then you'll see towards the end of the loop, it starts to understand color components. So if you look at things like the fire hydrant, the stop sign in the background, you'll see those start to turn red. You'll see the grass start to turn green. This particular shot was actually deliberately somewhat sepia toned. That was the look of the content, because it was trying to look like a kind of a flashback to a historical moment in the animation. So so the sort of sepia-ish tone that you get at the end is actually as the movie was. So there you go. There's an AI learning, and so you're seeing kind of how it kind of gets closer and closer to the target of what you're trying to achieve with it. So it's a kind of a complex example in the sense of a color AI is probably not what you're imagining we would talk about first. But it was using the most simple technique in AI now, which is training effectively neural nets or deep learning networks. So I'm going to talk a little bit about that and the advantages and disadvantages of both. So around 2017, there was a white paper about using attention networks. Now, attention networks have been used in AI before ChatGPT and large language models came along. But they were used effectively, they're quite heavy to run computationally. So they were used effectively to guide a deep learning network. So you would put an attention network on the side and effectively provide context to the deep learning network about the specific task you were about to give to it. And the attention network would do, as it suggests, draw the deep learning network's attention to the area that you wanted to focus on. And then a team, which then became OpenAI, basically realized that they could just train an attention network. The reason that hadn't been done up to that point effectively was just the amount of computation required to both train it and then run the network. And it wasn't sort of seen as a highly efficient tool. But what they found was when they got to a very large amount of data, the attention network now ran as effectively a network on its own, and it produced actually pretty surprising results. And if you spin forward to today, in fact, all generative systems now use attention networks as the underlying technology. Now, the first challenge between an attention network and a deep learning network is the number of parameters that are within the network. A deep learning network can operate even on thousands or hundreds of thousands, but certainly the biggest deep learning type networks will run on maybe millions of parameters. large language models require billions, and now they're starting to get into the range of trillions of parameters, which is quite a large amount of effective levers to pull within the network to get to your result. But as a result of these huge number of parameters, they exhibit effectively what looks the closest thing to actual intelligence that we have today. They certainly really make the Turing test kind of an obsolete way of measuring whether something's artificial intelligence or human. The net result of this huge number of parameters is that attention networks are really heavy. They're huge models. They take a long time to run, and I will talk about running attention networks, generative AI locally on a computer, but certainly it gives itself very much to the cloud, where we have very large compute resources available, and therefore you can run it in what looks like a practical timescale. By comparison, a deep learning network or a machine learning algorithm is very lightweight. In fact, they run on chip on your phones all the time. So neural nets do things like face recognition on your phone, and that's actually on the camera chip now. They really are very lightweight, very easy to run, and computationally inexpensive. The other challenge with for instance, a large language model or a generative image model is they require a massive amount of data to be effective. We're talking internet-sized data sets. Whereas deep learning networks, as I mentioned with the color AI as an example, can run on a much smaller amount of training data. So that obviously raises questions about where do you get such training data if you're going to generate one of these attention network tools. And we'll talk about that a little bit more later as well. Yeah, it's something to think about if you're thinking about getting into this space in terms of actually building your own tools. Machine learning, deep learning tools, you can build from scratch, basically. We did that at Sundog. We were literally starting with code, and we're using tools like TensorFlow to build the networks from scratch. You cannot really do that realistically with with an attention network and a generative AI. You need what's known as a foundational model. Once you have that, you can then modify that model yourself and make it work in a certain way that you want it to. And that's more practical if you're looking to develop your own in-house AIs. But the bottom line is that for something like a language model or a generative image or generative video model or those types of tool, you will need to go and get a foundational model that's already trained, because the amount of data that you would need on its own is going to be impractical. We're talking about a lot more data than, for instance, the archive of a big broadcaster or a film studio for training video. It's surprising quite how much data you need and how diverse that data needs to be to get to a foundational model. But with that comes some challenges because of what's in the data. So I'll probably discuss that a little bit more later as well. Unpredictability in large language models. So underlying a lot of generative image, which is very popular at the moment. And again, here's an image which I got from Leonardo. Da Vinci's something else. So there's an AI tool called Leonardo, which is what you're seeing a generative image from here. It's rather good. I was actually pretty surprised at how good that picture is. One of the challenges when you're generating images or language responses is consistency. So if you've played with any of these tools, you'll notice that you can keep hitting regenerate on an image, and you just keep getting completely different images back along the lines of what you've asked it for, and that comes to prompting, which we'll talk about a little bit more later as well. So you ask for something in a natural language way. So you say, I want a black and white picture set in the 1920s of a lady and a man in a speakeasy or something like that. And this would be the type of image you get back. But then if you hit go, you'll get a different image with two different people. And this is down to something known certainly in some of the models, such as stable diffusion, as temperature. And the temperature basically means the creativity factor of the tool that you're using, and it's sort of like randomness. So a higher temperature, and they typically range from 0 to 2, that value of temperature. A typical default value would be something like 0.7, and with that you would get different responses, but the outputs wouldn't be too crazy. They would look relatively good. But you turn that number up and it gets more creative, which effectively kind of means a little bit more almost psychedelic, I guess, and very imaginative, but not structured. So faces start to distort, hands have too many fingers or not enough, too many arms on a character, and it goes kind of weird. If you turn the temperature down, it will become less creative, but more consistent. So the results as you keep hitting regenerate would be more similar to each other. And if you turn the temperature to 0, you in fact get the same output every single time. Now, the interesting kind of point there is that there is an optimal, in inverted commas, output from the network. And that optimal, as far as the network's concerned, optimal output comes when you give it the value of 0, and it will give you that same output every single time. That could be useful if you're trying to generate something consistently. Playing around with those values allows you to start to bring some coherence to the work you're doing if you're trying to create, for instance, multiple images, or you're trying to produce some consistent video. So that's something, if you start playing with some of these tools where you can actually run them locally, you'll be able to play with some of those types of parameter. You can also play with things like seeds for randomness and so on. So large language models are context driven. They're all about context. That's literally their kind of party trick, is that they sort of understand context. Realistically, what a large language model is doing is outputting the statistical most likely next word based on the previous words that have come into it. So if you ask it a question, it's just outputting the words it thinks should follow on from the words in your question. And if you ask it to elaborate, it looks at the words of your question and the words it's just created, and then gives you the words it thinks should follow on if you asked someone to elaborate. So it's kind of weird that it's just a statistical model that produces the right next word. But the results are incredible of being able to do that. And it definitely exhibits on face value intelligence, which is, and it has underlying emergent properties as a result of the size of the network as well. And one of those emergent properties is that it hallucinates things. So it doesn't, and I think this is actually a really important point to stress. Large language models don't know anything. There are now some available which can reach out to the internet and do, for instance, an internet search as part of the response in order to inform the response on current information. But the model itself, that once it's trained, is just a snapshot of that statistical relationship. So historical things, it doesn't really understand anything. It simply outputs what it thinks are the right words. Now, sometimes that can result in a very good coherent response based on what the data it was trained on. But in other cases, it will just make things up. And there's no sort of real way to know what the network is doing in that sense. And so they are somewhat, let's say, they could be dangerous in the sense of, if you start using them and believe the outputs are real, then you could be led down a fairly dark alley with that content. So understanding how these models work is really important to their use. But they also exhibit creativity, and this is where we'll go now, looking at some of the examples of things that we can do with it. I just saw a question pop up. Is this technology used to restore old movies? Yes, it definitely is. There are some very good tools out there for things like upscaling, denoising, color transformation. I will talk about some more of that a little bit later. But yeah, absolutely, it is now starting to make its way into restoration. And actually, I think this will be something that once we have kind of off-the-shelf tools and services that allow you to run very large content libraries automatically through, you will be able to bring them up to date very quickly. And there's also one of the challenges with restoration is understanding what you have in your library. You may have multiple versions of the same content, but with slightly different edits, or different quality depending between different copies of a piece of content. And you can use, again, AI to determine which is the best one, which one I should use, and also look at things like the difference. So is this edit different to that edit? And then tease out like maybe two versions and create a single final master that is effectively your best possible version. The question of what you then do to modify the image is a very interesting one, because it could be something that you don't want to play with too much because you're losing the integrity of that original content. But you could very easily take all of the film grain out, upscale to 4K or 8K, and then bring the color up to date as well, and make it suitable for a normal streaming channel on an HDR TV. But you might feel that you've modified the content too much. We'll come back to that a little bit. So build versus buy very quickly. I've already kind of talked through this a little bit, but yeah, think about the amount of training data you need. Think about the expertise you need as well. It does take data scientists and computer and scientists who understand how to build these networks properly and how to curate the data and train the models. But as we've seen, even very large companies with very large teams can get it wrong. And I think that's actually worth remembering that, there's already a fairly high number, above 50% of development projects never achieve their goals. And that number is very high for AI projects, like in the 80 to 90% range of projects never get to full product or viability. So it is definitely a bit of a risk you would take on doing your own AI tools, but with the right expertise, there's certainly a lot of off-the-shelf open source tools, and you can build on top of those. And those are really that's kind of the most common method now for people building their own AIs in-house, is to take off-the-shelf open source AI and then modify it to their own needs. And if you are going to embark on training something like a large language model or a generative image model, you do need internet-sized amounts of data. So let's look at some actual practical use cases. Synthetic humans and what I'm calling lip synth. I only came up with that a few days ago, but it's more or less what you might know as deepfake. Now, deepfake is actually a combination of a number of technologies around voice and image. But specifically, one of the practical applications of this in film and television is to modify the mouth movements to match the audio. Now, why would you do that? Well, in movies and in TV, we make lots of different language versions. So we have some that are subtitled, and I'll talk about subtitling a little bit later. And we have some that are dubbed. And the dubbed versions, you have to work very hard with the script to make it fit the movements of the mouth that are already there in the original language version. And depending on the language you're dubbing into, that can look better or worse, because it's hard, obviously, to match words when the language is completely different. So lip synth basically gets around this by taking the audio and using an AI to regenerate the lips, basically. So you train on the original picture, which now gives the model the understanding of the faces of the actors. And then when they're speaking, you have the AI replace the lip movements with something that matches the audio. So you also have to train the AI on what lip movements correlate with what kind of spoken word audio. So this is, so you also need to use voice recognition. So this will, oh, actually, yeah, I was going to talk about something else as well with this very quickly. One of the other challenges with this is replacing the voice itself. You can do that, and you can actually synthesize a voice from scratch. And some notable actors have said that, for instance, James Earl Jones has sold the rights to his voice to Lucasfilm, so they can use his voice for Darth Vader, the Darth Vader character, sort of into perpetuity. So they're training or have trained an AI on James Earl Jones' voice so that they can then recreate his voice for future content, Star Wars content, with Darth Vader in. Now, this is a really interesting point because his voice obviously is extremely recognizable. And this is true, obviously, for a lot of, big actors that are popular worldwide. And they will have voice actors in different territories who are recognized by the audience of the voice as the voice of that actor. So if you were to, for instance, train an AI on James Earl Jones' voice, but then have it do the Spanish version, it wouldn't work for the Spanish audience because they are used to a different voice from a particular actor who always does that voice. So it's a really interesting kind of component of where this technology can go, and the reality of where we are today in the media industry. So definitely something to think about is that you could go fully synthetic with a lot of this stuff, but do you want to, and will the audience accept it? One of the other challenges with this is what's known as the uncanny valley, which is essentially when you get something that's pretty close to what you're looking for, but is not quite real enough. Now, this face image, I think this one's very interesting. Firstly, there is a really obvious artifact on the nose that was spontaneously came out of the generation of the image, and I don't really know why that happened with the highlight on the nose, but it's weird because it's just like a blob of white stuff on the tip of his nose. It's like he's got a little bit of tissue paper stuck there or something. And you would notice that you'd see it straight away when you're watching this, and even more so if this is a moving image. Also, his face is a little bit too, his skin's a bit too perfect almost, although it's quite creates some blemishes like freckles and so on, and there is skin texture in the image. I think it's fair to say that everyone looking at this picture would know that wasn't a real person. It's close, but not quite close enough. And that's the uncanny valley. It's a real challenge with a lot of this technology, that if you find yourself in that space where you're nearly there, but not quite, it's almost worse for the audience than if you were miles away and it looked very synthetic. And therefore, the audience, the viewers' brains would just accept that it was synthetic and move on. When it's nearly human, but not quite human, it's a lot harder for your brain to cope with, and it actually creates a feeling of genuine unease. And this leads to the phenomenon known as the uncanny valley. So it's a very interesting challenge with generative AI, that you have to get kind of beyond that and into the space where it really does look real for people to actually accept that it's real. Doing that on a cinema-sized screen can be more of a challenge, but the tools are moving on incredibly quickly, and certainly some of the more cutting-edge tools that we are starting to see come to the market are absolutely capable of synthesizing image at cinema screen size and have that look acceptably real, and the audience would certainly not question that there was something funny going on with regenerating parts of the image or the whole image. One of the things you can see in this image that looks pretty realistic is the fully out of focus background. It's done a really good job on that. I actually think that could easily be out of a real movie. So moving on. Dubbing and audio description is an area that we use AI as well. One of the challenges at the moment with synthetic voices is getting an emotional match. For instance, if you do a translation of from one language to another and then create a synthetic voice in that language, it's quite hard to basically carry the emotion across with the translation. So there is work on tools to do that, but at the moment, what happens is you typically go through a speech recognition tool that will then generate text. That text gets translated through a translation tool, and then that text is turned back to speech using voice synthesis, and that then becomes actually slightly flat and unemotional. You can train a specific voice to carry a lot of emotion, but it will carry it almost all the time. So it's kind of like you kind of get one thing or the other. You can't have that kind of emotional range that an actor that would exhibit, because performances are very nuanced. I think a really good example of that actually that you see in the real world is if you ever watch Instagram videos or TikToks, people quite often use a synthetic voiceover describing what's going on, and it's so obvious that it sounds synthetic. It's very sort of stilted, and the voice really it's kind of obvious to your ear that it's not real. It doesn't carry the right cadence, the right prosody, and the way in which it kind of progresses through a sentence. I just noticed somebody has noticed the face had different color eyes. That's actually, I hadn't noticed that. That's brilliant. So yeah, performance is really nuanced, and we still find voice actors are still best here. We don't want to replace them with AI at the moment because they are, very much still giving us the best results. And so in the industry, that is pretty much the way it goes. For accessibility and for lower budget stuff, you might want to start thinking about synthesized voice. And actually for things like audio description, that actually starts to make a little bit more sense, where it's not something that you have to have as much emotional range in there. In fact, you want to avoid it to some extent, because you don't want to necessarily interfere with the narrative of the TV show or the movie. And the models are improving. And to be honest with you, everything changes so fast. I wouldn't be surprised if someone launched a full tool while I've been doing this slide that I just don't know about yet. So yeah, I think this is true, to be honest, across all of the things that you'll see today. The models are constantly being improved by people, and a better version is always going to be available tomorrow. There's some really exciting applications in live. That's one area where some of the synthesized voice has a lot of potential, because you can do things in real time using these tools, which again, like for traditional dubbing pipeline, you have to get an actor into a studio and do the voice and so on, and actually you can't necessarily do like foreign language dubs in real time from, say, live sports and that kind of thing. So these are areas where certainly we're looking at, and I think you will see a lot more on the synthetic voice side over the next coming months and years. And I do actually think that's a space where there'll be a lot of new products coming to the market, and you'll start to see that as an audience, that you'll be able to select a language but hear the commentary from a commentator, the original language commentator, but in your with all of their expression, but in your language. So there's be pretty interesting stuff coming in there. Subtitles and translation. Again, this is an area where language models are really changing how we look at this. It's still quite common to do translation using people, humans, and we certainly have huge teams of translators. And for what we would describe as premium content, tentpole movies, that's certainly the expectation of the film studios and the broadcasters, is to have the absolute best quality. They want manual translation. But for live subtitling and translation, AI tools are really right there now. They do a very good job of speech recognition and turning that into then obviously on-screen text for captioning, and also translating that in real time. They do captions such as so for hard of hearing captions, there's two things. There's obviously the dialogue, which is being expressed on screen as text, but also you will have certain things like sound effects in this example here, spaceship engines. When I first generated this image, I didn't notice the spaceships and I didn't ask for them either, but there they are. And but I decided to use it as a good example here, that you would have to understand the context of the image in order to generate that caption. You can't necessarily do it from just the audio or just the picture. So you need to have a multimodal approach to generating captions. And for that reason, at the moment, I haven't really seen any tools that can fully do captioning. And again, that means that for hard of hearing captions, we rely on humans to make those decisions and understand the context of the caption, because you can't even do it for all of the things that are going on. You need to do it for things that are important to the narrative. So that's why you would, for instance, in this case, point out that the spaceships are overhead through the noise. Large language models can be used for translation, but because of their creativity, they can quite easily go off track with translation and start to get a little bit too too creative with their answers to a translation. So they can do a pretty good model from style point of view, and actually they're very useful for instance, applying historical drama. You can ask the LLM to create translations that have like old-fashioned turns of phrase and so on, and that works pretty well. But as an overall translation, we still find that neural machine translation is more consistent. So you know, you can imagine you could use a combination of those things, and that will give you a better result. But certainly where we do use AI for translation, we still use neural nets, so traditional kind of deep learning networks for that. We still require humans. At the end of the day, we still need people to check these translations, and often fixing quite a large percentage of them, depending on the success of the translation tool. And actually, what's interesting there is that it's the harder translations are the ones that take longer for people to do, but they're also the ones that a machine translation will likely get wrong as well. So actually, you don't reduce the effort. Like even if you make 60% of the subtitles from a machine translation, the 40% that you're left with are harder to do than the 60% that weren't, that came through okay. So you don't reduce your effort by the equivalent amount of percentage of how many subtitles were good versus bad. So yeah, that's certainly an area that is in development. But if your quality threshold is low enough, it's quite common for some content now to just use machine translation from start to finish. Let's talk about generative image. 6 minutes. I'm gonna have to be really quick, I realized. So, well, there's loads of generative image tools. They're freely available. There'll be some links in the email that goes around after the talk, which will let you go and have a look at some of those things. If you've got a good gaming machine at home with a reasonably powerful GPU, you can run these tools locally. You need to learn to prompt, and this is really important kind of area now. Prompt engineering is a whole new space and role, and different models are better at different types of image. So you get from different generative AIs, you get different results, and some are much better at photoreal than others. We mentioned, I'm going to really rattle through this now, realizing I've only got 6 minutes. You mentioned earlier about restoration. Well, one of the things that you certainly used to hear when you talk to people about frame rate conversion or upscaling is you can't create something that wasn't there. You can't generate something that wasn't there. Well, actually now we can. Generative fill allows you to upscale and actually fill in the texture detail using the generative AI. This image here is actually entirely generative. It's just to show you kind of the quality level you can get to with the Gen AI. This was totally done through a prompt. There are a couple of weird things going on there, but mostly this image looks pretty good. And certainly if you were using this to, for instance, upscale and get better road texture, but you still wanted motion blur in the wheels of the car, then absolutely these are things that AI can understand and do. So also now there are a lot of tools out there to help you workflow AI, and it's really becoming something that's more or less like a visual effects process. So this allows you to get very specific about the type of image you're generating and control the output of the AI. Now, up to yesterday, I would say that what you get with any generative AI is something that you'll get a whole image out, but you can't really tweak that image and say, I like that image, but I want to just change that one thing in the background. But as of yesterday, the early look of LTX Studio has exactly that control. So now there will be tools coming to the market in the next few months that will allow you to actually generate an image. And if you don't like a specific aspect, say you don't like the person in the image, you want to cast in inverted commas a different person, you can do that. You can change the color of one item in the image, and the system will be able to do that in the generative AI without having to change all the rest of the image. And up till recently, that wasn't possible. Another area that we're using AI a lot now is in scanning. So 3D scanning for objects on set, for instance, and actors and so on. There's a very new methodology called Gaussian splat, which this scan that you're seeing here is actually done just using a mobile phone. And it's a very lightweight model that can then be run locally and gives you a very photoreal 3D model. So this is another area where we're using AI quite heavily now. So because of time, I'm going to very quickly move on to generative video. So one of the things that was up until recently very difficult to achieve was consistency in generative video. And a couple of weeks ago, OpenAI showed off Sora, which is what you're seeing here. And Sora actually can do that. So this is an entirely generated image. And what's really interesting here is that the floor stays very consistent. It's actually had to generate all of those artworks as well as the video of the artwork. So it's generated all the artwork and the video itself. So it's incredibly powerful kind of tool. And if you think about what it would have taken to create this shot in the past, that would be quite a big effort, not only to set up all the old vintage TVs, but also to get the video for each TV to run. So this would have been, but now this is like a few moments of prompting, and you can get this type of picture out. It's very good at things like understanding reflections. So you'll see the reflection of in the window changes as it goes past different objects in the background. Again, these were things that were very, very hard to do until recently. Something that the visual effects community have spent a very long time doing is getting fur to look real and giving objects a real sense of gravity and weight. And this one is incredible. All of the things going on in this image we're thinking about. Those puppies have weight, they interact with each other, their fur moves in a very realistic way, and there's even particle physics with the snow. So there's so much going on in this just from a generative image that effectively would be a really, really complex visual effects process to do this synthetically. So the technology is moving on incredibly quick, but it still does weird stuff. And so here's an example of spawning. And this is actually quite a common challenge in generative AI, is that things spawn. So you get this kind of moment where the system just starts to create stuff out of nowhere. And this is a form of hallucination. So I quite like this, just these red pandas just appearing out of nowhere and going off crazy. But again, they have weight and gravity. They seem to move around realistically on the surfaces that they're on. It's pretty amazing, to be honest. They even seem to know to jump out of the Petri dish. I mean, how did it work that out? Anyway, so there's a lot going on there, and it's a pretty interesting area. I wanted to spend a bit of time on this, but I think I've run out of time. Polly, do we have time for Q&A, or are we
We
gonna?
do. We've got a couple of questions in the Q&A.
Oh, okay.
Yeah.
Right.
So what I'll do is I'll just go for the first one. We've had someone who they're doing a thesis focusing on AI in audiovisual subtitling, which is fantastic. And they wanted to know, I'm going to paraphrase so we can try and get a couple of questions in.
Yeah.
Are there any AI-based platforms that deliver professional level audiovisual subtitling? I think you kind of talked about those, but maybe didn't name.
Yeah, I mean, there are some off-the-shelf ones, and it's actually something we offer at Deluxe as a professional service. So yeah, there's quite a few actually out there. Given that it's a space that is actually part of my day-to-day job, I'm probably not going to name all the competition
Yeah,
right
of
now,
course.
but certainly, feel free to connect me to that person, and I'd be happy to talk to them offline about it.
Yeah, of course. That's probably a better way to answer that actually, because they've popped a couple of questions in there.
Okay, cool.
So I think maybe a follow-up might be a bit
Yeah.
easier. Someone else also did bring up earlier the kind of IP nature of this, and I know that's
Right.
kind of what you were sort of about to talk about there. So I don't know if you just wanted to touch on that.
Yeah, so at least in the US, the Copyright Office in the US has determined that currently no one owns outputs from generative AI. Neither the person who prompted the AI nor the company that made the AI that made the output. So there is no copyright available for generative AI. That means no one owns it. So all these images that you're seeing here that I created in various Gen AIs, if you've been like screen grabbing them and using them, I can't really do anything about it because I don't own them. But neither do the companies that made them. So it's rather interesting area. I think that is going to develop in terms of ownership and also training data. I think that's probably a bigger area, a bigger challenge is understanding who owns the rights to the training data and whether these models have been built on training data that they had the right to use. Certainly, I think we'll see a lot in that space over the coming months and years. I've just seen a question about deep fake.
Yeah, did you?
One of the challenges with well, certainly illegal content is something that all of the companies generating these tools are working very hard to make sure that they cannot generate. There are ways to get around their guardrails, unfortunately, and this is quite an area in of itself, known as jailbreaking, from the old sort of mobile phone hacking days. But there are certainly is a lot of work to try and make sure that you can't produce harmful content with these tools. And the other thing, and particularly around deepfake, is tagging stuff such that you can determine that it was generated by an AI. And again, a lot of these tools are now building in effectively kind of watermarking technologies that will allow you to determine both from metadata or from analyzing the image that it was created by an AI. And that's embedded in there. And from an ethical standpoint, the larger providers of these tools want to make sure that if someone's generating an image that looks real, you are able to determine it's not real. And I think that, again, is going to be a really important area over the coming months and years, especially when you're coming up to things like general elections. In the US, they've got a presidential election this year. I think we're going to see a lot of misuse of this technology in that space. So from a responsibility point of view, companies definitely are and should be looking at how they make sure people are able to determine what's real and what's not.
And I'll just quickly chuck in on the very last minute spare. Someone said, how long until Gen Video can have matching audio?
Was it LTX Studio, which will be launched in the next couple of probably in the next 2 months, I think. will actually generate audio, music, dialogue, and sound effects to match the video. And there are some tools right now available that you can put in video and it will generatively create sound effects to that video. So those tools are all already available. I don't know if I put any links to those particular tools in the chat, but certainly there are companies doing generative sound effects. And as I mentioned, LTX Studio will have that built in. So it will do generative sound to go with the generative video that it creates. So yes, 2 months max before you can do that.
Amazing. I just wanted to draw everyone's attention to there's some information in the chat. So we've got some feedback forms there, and there's an editable CPD certificate for you as well. Just thanks so much, Rich, for joining us today and talking about literally yesterday and today's news in this area. I know this is a really fun time for you, and it is literally why you're out in LA, isn't it? Because you're normally based over here. So thank you so much for giving us this presentation.
Thank you for.
And this is recorded as well, so anybody can catch up if they want to. And Gemma's also putting in the chat, she's going to send out an email with the links and the resources. So just watch out for that in your inboxes. Thank you so much, everybody.
Thank you very much.
Thank you.
Bye-bye.